Time to work on determining the number of valid hosts on a subnet. And as with the valid subnets determination that we just learned how to do, the actual subnetting here in this question type has already been done. And we need to come up with a value regarding that subnetting. And where before it was valid subnets, here it's going to be valid hosts on the subnet that we're given. And we start by arriving at the number of host bits. And that is a very short trip. A lot of times, if you're given the mask and prefix notation, you don't even have to do any writing to make this happen. It's 32 minus the number of ones at the beginning of the subnet mask equals the number of host bits. That's it. That's all there is to it. So once we have the number of host bits, what do we do with it? We put it into this formula, which is handier, dandier, and a little bit different than the one you learned in the last section. We're going to take 2 and raise it to the power of the number of host bits, which makes sense because we're calculating the number of valid hosts on a subnet, but we subtract 2. Then we have the number of valid hosts. And on exam day, make sure you take that 2 off because it can make the difference between getting the question totally right and totally wrong. You'll see exactly what I mean as we walk through this example using the network 200.10.10.0/26. Well, first off, without even looking at the screen, you know we got 6 host bits because we're given the mask and prefix notation /26, 32 minus 26, 6. 2 to the 6th power, 2 times 2 times 2 times 2 times 2 times 2. See, I didn't trip that time. That's 64. Now, if I were writing a practice exam, which I will be shortly, but if I were writing even the real exam, and I was giving you this question, and I was giving you multiple choice, I would guarantee one of the choices would be 64. And I guarantee you 20% of the people minimum taking the exam who had not taken my course, well maybe 50% that way, they would say, oh, 64. You gotta subtract the 2 when it comes to the number of valid hosts. So the actual answer is we have 62 valid hosts on 200.10.10.0/26. Now, 2 big differences between this determination and coming up with the number of valid subnets. Now it makes sense, but I'm going to point this out anyway. When you're determining the number of valid hosts, you need to know how many host bits you have. When you're determining the number of valid subnets, you need to use the number of subnet bits you have. Now, why do you only subtract the 2 in the valid host calculation? Where are those 2 coming from? Well, there are 2 addresses in every subnet that are considered unusable by hosts. The very first address in the subnet is the subnet number itself. So we can't assign that one to, a printer or something like that. Now, the last address in the subnet is the broadcast address for that subnet. Now, I know I've told you the broadcast address 255, 255, 255, 255, that is an overall broadcast address, but every subnet has a broadcast address of its own. And that is the broadcast address, the last one in the subnet. So the first and the last addresses in any given subnet should not be used by hosts. And for now, I'm asking you to trust me on that because you're going to see very shortly when we're calculating the actual range of valid IP addresses in a given subnet and or the broadcast address for that same subnet, that concept will become a lot more clear because we're going to go into the bit level on that. But again, your first and last addresses in any given subnet are considered unusable. So that's why you subtract the 2 when you're calculating the number of valid hosts. And speaking of determining the subnet number of an IP address, by golly, that is our very next skill, and we're going to hit that on the very next video. See you there.